Theorems and Proofs. Theorems and Proofs. In this lesson, you will learn how to use axioms, definitions, and theorems to prove properties of real numbers. So let's look at some definitions. An axiom, also known as a postulate, is a statement that we assume to be true. For example, all right angles are congruent. A proof is a form of logical reasoning from hypothesis to conclusion. A theorem is a statement that can be proved. For example, the sum of the squares of the side lengths of a right triangle is equal to the square of the hypotenuse. You also know that as Pythagorean theorem. A corollary is a theorem that can be proved easily from another. For example, if two angles of a triangle are 50 degrees and 70 degrees, then the third angle must be 60 degrees. Show that for all real numbers a, b, and c, if a plus c equals b plus c, then a equals b. So we want to prove that if a plus c equals b plus c, then a equals b. We're going to do what's called a two-column proof. There are other kinds, but in this class we'll just look at two-column proofs. So here are your two columns. You have your statements on the left and your proof on the right. Our first statement is that a, b, and c are all real numbers, and a plus c equals b plus c. And the reason that we can state that is that they are given to us in the original problem. They gave us that a, b, and c are all real numbers, and a plus c equals b plus c. Now we're trying to prove that a is going to equal b. So let's see what comes next. Well, from that we can say, all right, well, we know that negative c is a real number, and that's just your property of opposites. So we can take our negative c and we can add it, we can take that negative c and we can add it to both of these expressions. And the reason we can do that is the addition property of equality. We're adding the same thing to both sides. Our next step is to regroup. We're moving the parentheses from being around the a plus c to now being around the c and the negative c. And then again, we do the same thing on the other side. And that's the associative property of addition. Remember, when we move the parentheses or brackets, that's the associative property. Then our next step is that we can make c plus negative c equal to 0 on both sides. And the reason we can do that is the property of opposites. Anything plus its negative is 0. And then finally, these three dots mean therefore. So therefore, a equals b. And the reason we know that is the identity property of addition. Remember, the identity property is when you add 0, it becomes itself. So a plus 0 equals a, and b plus 0 equals b. So we have gone from the if statement and shown logically that the then statement is true, and here are the reasons for each step. So that's your basic proof. You have statements that follow logically from one another to get from point A to point B, or from the beginning to the end, what you're trying to prove, and you give reasons for each of those statements. That's a basic proof. Now keep in mind, in this class, we're not going to do a lot of proofs, but I do want to help you understand the basics of proofs, so when you get to geometry, you'll be familiar with them. Let's go over a few other vocabulary words that you might need to know. A converse is when you switch the if and the then in a statement. So for example, if your original statement is if a triangle has a 90-degree angle then it is a right triangle. So the converse is if a triangle is a right triangle, then it has a 90-degree angle. So they are converses of each other. A counterexample is an example that makes a statement false. And an if and only if statement, and this is the shorthand for that, is when an if-then statement, like the two we have up here, and its converse are both true. So if we take a look at these two statements, the first one is true, its converse is true, so we can form that into an if and only if that reads like this. A triangle is a right triangle if and only if it has a 90-degree angle. And those are your basics for theorems and proofs. Again, we're not going to do a lot with proofs in this class, but I do want you to start to get familiar with them so when you move on to later courses in math, you'll be familiar with them already.